30 p.m. So before we begin the session, I'd like to share a few important instructions with all the participants. Kindly note that last 10 minutes of the session will be exclusively reserved for interaction and queries from the participant. Participants are requested to post their questions in the chat box during the lecture so that they can be taken up during the question and answer session. We also request all the participants to keep their microphone muted throughout the session and unmute only during the last 10 minutes, that is during the question and answer time. The feedback form for each session will be shared at the end of session. We request all the participants to kindly fill the feedback form as it is mandatory. So as our session one speaker is available here, it is my proud privilege to introduce and welcome today's esteemed resource person. We are honored to have with us Dr. Yashwant Savle, sir. Very welcome to you, sir. Dr. Yashwant Savle is currently working as faculty member at MIT's Madhav Institute of Technology and Science, deemed to be University Gwalior, and is former assistant professor at Vellore Institute of Technology, Vellore, Tamil Nadu. He completed his MTech and PhD in electrical engineering from Maulana Azad National Institute of Technology, Bhopal. He has been recognized as one of world's top 2% scientists by Elsewhere and Stanford University, USA, in the year 2023 and 2025. He has also served as chair of IEEE PES Madhya Pradesh chapter and is senior member of IEEE community. With 15 years of teaching and research experience, Dr. Salve sir has published 56 research papers, including 2 books, 24 SAI journal papers in reputed publishers as such as IEEE Elsewhere, Wiley, and Springer. Research interests include renewable energy systems and power systems, Internet of Things, inverter,
मैं कुछ
converter,
बोल रहा था
operation in microgrid.
दे दे मैंने
Someone please turn off the mic. Mr. Abhay, can you please turn off the mic?
अरे देख मैं चला तो ना दीदी नहीं बोला
Uh, Amol Patil sir, please mute everyone. Okay, sorry for the interrupt. Additionally, he served as an editor for several renowned journals, including Wiley, Springer, Hindawi, and he has worked as a guest editor for MDPI, Hindawi, and Frontier in Energy Research. He has delivered keynote addresses at various IEEE conferences and has conducted expert lectures at multiple universities. Sir, we are extremely grateful to you have you with us today. I now request Dr. Yashwant Savle sir to kindly begin the session. Over to you, Dr. Yashwant Savle sir.
Thank you, Dr. Rajni, for your kind words regarding my introduction. Thank you very much, and thank to all the organizing team also. Shall I start to share my PPT?
Yes, sure, sir.
Oh, okay. Is it visible for everyone?
Yes, sir. Screen is visible. PPT is visible clearly.
Okay, so my topic is based on evolution of solar technology and its PV system design. So in this lecture, we will try to cover the basics of why renewable energy is important, what is the scenario of renewable energy, and what is the major part that is played by the PV cell or PV system. That also we will discuss. After that, we will try to understand how many types of system we can design with the solar PV system, maybe with integrated with another systems like wind, biomass, others like grid connected, off grid connected, building connected. So many types of system that also we will try to discuss here. uh, I also plan to design one system, but actually my software is not running due to some issue. So, but I just inform how we will modeling, how we can put the data. So those things we will try to cover in this session. So first, I start with the introduction. So why we are not India only, all over the world, they are shifting towards the renewable energy sources, because everyone know, because the fossil fuels are very limited and they are not lifelong with us. So and our load demand is day by day is increasing continuously, and because the industry application and other populations also increase, so their load demand is increases. So we need to shift towards the alternating energy sources. So in that the solar system is very important player to generate the electricity and fulfill the load demand for industry, commercial and agriculture wherever it is required. Those things we will cover through the solar panels or solar energy. So here you can see in the major participation of the all the renewable sources to generate the electricity worldwide. So here you can see you can see from zero to year 2020, the solar portion in this pink shade here, it is very less as compared to this conventional. My cursor is visible here.
Yes, it is visible.
Yeah,
Yes, sir.
okay.
Yes.
Okay, so here we can see the comparative production through the conventional or non-conventional. So, because previously the PV solar cells are available, but their production of electricity is very less because their efficiency is very less, around 8 to 10%, previous 10 to 15 years back. So their use is very limited, and they are used for satellite application or some major application. There only we can retire, but day by day the technology is increases, and uh, their production and efficiency that also increases. So you can see here up to 2060, you can see the major electricity production worldwide through only the solar panels. Okay, so and the conventional that fossil fuel production is very less, but other participation is also higher. Those are under the renewable energy sources. So this is the scenario going on to 2060, because all the countries they set their target. They are decided to produce zero emission. So every country like India also decided up to 2070 they don't want to produce any carbon emissions. Similarly, other countries also set their targets. Okay, so now I go to next slide. Okay, here also you can see the solar installation capacity by the region. So in worldwide, we divided in seven portions. So here you can see the electricity production year by year. But this data is year 2016. Now, if you compare this 2016 here in this tabular form, we can see here the European countries having 74% of electricity production through the solar panel. So that time is the biggest player to generate the electricity. But now their electricity production is somehow lacking as compared to other countries. So here you can see the European now only 12 to 14% globally, as Asian climb dramatical. Similarly, if you talked about the East Asia, including China and India, so there you can see the mostly solar power production generated through the Asian countries, and it is around 40 to 45 to 50%. Similarly, North America that also increasing 9%, but it is same as it's not major change in North America also. In 2016, it is around 9%. Now currently it is 10 to 12% only. Similarly, the other countries. So you can see the Asian country, they are playing very biggest role to generate electricity because their geometrical structure and the solar that summer time is longer as compared to other cold countries. So here we have great potential to generate the electricity through the solar panels. Now, if we discuss about the Indian scenario, what India are thinking regarding the renewal. So, India set some targets, and they are already achieved few targets like decarbonization of electric infrastructure that is decided by Indian government up to 2070. They are trying to generate zero carbon emission. Then the next they plan to install 175 gigahertz of renewable energy power plant up to 2022, and that also achieved in within a set time duration. And our next target is around 500 gigawatt by 2030. That is just doubled, more than doubled of the previous one. And that work is also going very fast. We are having a big setup of solar power plants. So this target of 500 gigawatt not only including solar, it also including the another renewable sources like wind, biomass, geothermal, hydro. So combinedly, we will connect this collectively. We can achieve this target up to 2030. Now, the another one is around 2080 280 to 300 gigawatt solar power we already installed and in plan, and but generation is not because from solar power plant the current installation capacity is around 132.9 gigawatt, and this will increase uh, after a few years. So these are the targets set by the Indian government, and they are working hard to achieve these targets. Now, if we talked about what is the scenario previously, so you can see according to National Survey of Indian Energy Audit Analysis, around 733 million individuals or around 93.9.3% population, they are without electricity. It means we have electricity everywhere in India, but we cannot say that they are totally electrified because they don't have electricity access for 24 hours. Some places we have only 4 hours, 8 hours, 12 hours, because they are hilly area and not priority area, or not don't much revenue we will recover from that locations. So still we can say that our few areas they are not totally electrified. Then, if we discuss about the African countries, they are around 77% of global population without electricity. So, this is the report by the CWW indicate around 3% without access to electricity in India. So, and now if we discuss about in current year is around 0.2%. So you can see according to this tabular form, here, these are the state-wise data is given here, and that comparison between year 2013 to 2025. So you can see state-wise there are 80% of rural and 5% of urban population. They don't have electricity in 2023. Similarly, Bihar, West Bengal, Assam, they don't have electricity of that much of populations. But if we talked about current scenario, now only 0.2% of people, they are not able to access the electricity. But that also we will fix in a few years to electrify for 24 hours. Now, here also you can see the comparative analysis of the power generation through the renewable energy sources. So our major focus is on the solar panels. So we are not going to discuss on wind, biomass, or hydro. But here you can see the installation capacity in 2012 is 941. Similarly, in 2015 is around three times to that one. Then after 2017 is again increases three times, then again 22 is increased around 10 times. So year by year we are increasing our solar installation capacity. And if we see the current solar energy power production is around 132.8 gigawatt. So that is the our growth, and we can see how fast we are going toward the zero carbonization, because as everyone know, this solar power plant, they don't emit any any emissions. Okay, now, why? What are the reason why we are shifting towards the renewable sources or solar energy power generation? So these are the few reasons which attract worldwidely to shifted conventional to fossil fuel to renewable energy sources or solar energy. So first, if we discuss about the environmental benefits, so environmental benefit, if we go through with the solar energy, it means we do not produce any emission, so our environment is pollution free, and we can protect the ozone layer and also human health. Then second is the improve the public health. So if environment is not polluted, it means we can take clear or zero carbon emitted air, so our health also good. The third one is vast and inaccessible energy supply. It means we no need to pay any cost for the input resource. Like the solar radiation is free of cost, available abundantly in the environment. So no need to pay anything. It means our actual cost of the power production through the solar energy is around 2.5 to 3 rupees only. If we compare with the fossil fuel, that cost is around 10 to 15 rupees. So it means we reduced our final per unit cost around three times, due to because of the free initial free input cost for resources. Then next one is the job creation, HDMI and other economic growth. So job, it means suppose that these kind of power plant we can install anywhere wherever the solar potential is available. It means suppose that some hilly areas are there, or some rural area, there the electricity is not available, and government or MPB or the Maharashtra government or other any government, they are not ready to install the power plant for that location, because the population for that particular location is very less. So the revenue is very revenue they will not recover in few years. So that is very difficult to install the electricity through the government organization using the conventional sources. So we can install these kind of solar power plant at that particular location, and they can generate their businesses also. They can open the shops and uh, other commercial industries, so that they will get jobs. The another one, HDI, it means the Human Development Index. Suppose that if they are getting job, it means their living standard also increase. It means there we can open the hospitals, schools, and other social activities that also we can do. So their living standard ultimately increase. It means their human development index also increases for that particular location. And because they are getting job and living standard also increase, it means they are economically also strong. The next one is the more reliable energy system. Why it is more reliable? Because this resource is available every time. It will not go as similar as like fossil fuel. So it is available every time. So we can access electricity every time with this solar radiations. But if we talked about the reliability in terms of technical term, so reliability is less as compared to conventional sources, because the solar radiation is available around 8 to 10 hours in a day. So we need to install some another equipment like battery storage, like diesel generator, if you want 24-hour of supply. So there's a two meaning of the reliability here. One is the lifelong available of the resources, and if we talked about technically, so technically it is we cannot say that it is 20 fully 100% reliable system for solar energy. Not only solar, for all the renewable energy sources, we cannot say they are reliable for 24 hour to generate the electricity. This is the major constraint with the renewable energy sources. The next one is the cost is predictable and non-influenced by the fuel price. Why? Because their input fuel is free, like solar radiation is free, wind speed also free. Then if you talked about the biomass fuel, that also free. So all the renewable sources, they are freely available. So we can predict how much cost for that one. Suppose that if we install some rooftop setup, so we can predict now their cost of per unit is around 2.5 to 3 rupees, and that cost until the project life of the that off-grid system, it means it will not change. But if we talked about the fossil fuel, their cost today 7 rupees, after 1 year 2 year it is 9 10, or it is increased, because they are depend on the coal, oil, fuel. So that price is changed internationally, so their price is also changed per unit. So that is the another major change with the solar energy power production. The next one is the energy transfer requirement reduction. Why? Because these kind of power plant, this kind of solar power plant, we can install near to load center. Wherever the load center is the load center, there we can install these kind of power plant. So no need to transport energy from one place to another place. If we talked about the fossil fuel power plants, they are installed far away from the load center, and kilometers of distance we need to cover, and then we need to distribute the electricity to that load center. So more number of equipment are connected, too many losses are there. So these kind of things also we can avoid through this solar power plants. Now coming to our main focus on this solar power plant or solar cells. What is the solar cell? So this is first implemented in 1839 by the Alexander Inoman Becquerel. After that, the first solid state solar cell was built using the selenium with 1% of efficiency. You can imagine it's only 1% of efficiency. So that time it is very difficult to utilize broadly. Then after around around 70 years, the another implementation and modifications done in the solar cell, so that silicon solar cell is come, and it has efficiency of 6%, and which is developed by Bell Lab. Okay, and which is begin modern to fertilize to photovoltaic system. The next one is the early application was very limited because it is utilized only for satellite application due to very high cost and very less efficiency. But now if compared to that one, nowadays there are four type of solar cell generation are available. So present, future, and the next upcoming generation, what is the going on the solar panel, that also we can discuss here. So if you talked about the first generation which we are utilizing currently, that is the two type. One is the monocrystalline silicon, and another one is the polycrystalline silicon solar panels. Their efficiency is around 15 to 26%, which is depend on the manufacture or the material which is utilized for the solar panel. What is the key features are there? They are based on vapor basic crystalline solar silicon. Their efficiency is high, lifelong is around 25 year, mostly is 20 to 25 year. After that they are not useful. The limitation for this, they are the high manufacturing cost, rigid and heavy. Because nowadays, if you see the panels, they are very heavy, and their manufacturing cost also little bit higher. The application for these kind of solar panel for rooftop system, off grid system, then utility grid connected system, that also we can utilize. Then the next generation, they are having three to four type. One is the amorphous, then silicon, then cadmium, and then tellurium. So these kind of solar panel also manufactured, and their efficiencies vary from 8 to 23%. Their key feature are thin film and semiconductor layers. Their advantage is low material uses and flexible lower cost. The major advantage of this second generation solar panel is they are very flexible, so we can utilize anywhere for any application, and they are portable also. So we can utilize for so on cars, on parking, on another folding material there, and some building, that building interior PV panels, they are also available. So these kind of application we can utilize using the second generation power plant. Then the third generation, and which is very drastically uh, 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 increase the efficiency of the solar panels. Like there is the perovskite organic, then dye sensitized, then multi junctions solar panels. So these are the current research work, and many researchers are working on this. They are trying to hard to increase more efficient and more powerful of that solar cells, and also focusing on their costing is try to reduce, because they are little bit higher cost, but their efficiency is around up to 30%. And it will in some lab, in some research paper, they claim around 36% efficiency also. So they are working very hard on the chemicals or materials to increase the efficiency of these perovskite organic solar panels. So it is a very advanced material and mono structure material. It is very lightweight, low cost, and processing very high absorptions. So the limitation for this one, the stability issue is there, and one is the major impact is their life cycle is lifespan is less as compared to first generation, and they are still under research, because everyone is trying to increase their costing as well as their life is to increase their lifespan. So the typical application for R&D application, then flexible electronics, then indoor PV system. There we can use this third generation solar panels. The fourth generation is the tandem stem, quantum dots, and transparent and hybrid cells. They are also very useful, and in coming years, the we will replace whole system of the first generation and second generation, the mostly power generation through the second through the third and fourth generation of the solar panels. So this fourth generation is also very experimentally high, complex, and scalable challenge, because we cannot more scalable for this, because their efficiency is good, but the costing and other parameter are still under research. So these kind of solar panel we can utilize for smart windows, space tech, future building integrated power systems. So these are the four generation of the solar panels which will come. The next three generation will come in few years. So here we can discuss about first every generation. So first generation there are the two type of solar panel. One is the monocrystalline, other is the polycrystalline. And then efficiency and this parameter we already discussed. If we go through with their structure, here you can see this is the monocrystalline PV panel, and another one is the polycrystalline PE panel. So the major difference you can see is the structure. They have the a very sorry, yeah. So they are formed in the bar and the cut into vapors like this. This is the age you can see there. This is for monocrystalline identification. And if you go through here, you can see one single line here. For that, we can say that it is the poly solar panels, crystalline panels. Then second one, that also we discussed their efficiency, advantage, disadvantage. And if you go through with their structure, you can see here the most advantageable feature of this second generation is they are very flexible. So we can utilize these kind of applications also. These are the structure for that one. The first one is the glass which reflect the solar radiation, and the another one is this transparent conductors. So because the heating, the conductor electrons and holes, they are acting and collide and then generate the electricity. Similarly, their internal structure also mentioned here. So these are the their manufacturing layers on which they are. As I told you, each cell of the panel they generate around zero point 0.5 volt. So if we are creating one panel or array, so we need to connect in series or parallel connections so that they will generate the electricity. Uh, Now, if we discuss about the third generation, so these point also we discuss, but their diagram like this. So you can see there's a tandem solar cell. So in that also, this is the upper layer which is the reflecting glass, and here's the perovskite material, and this is the selective contactor for that one. So this is the internal structure of this third generation power plant, the solar panel. Now the fourth one is the that also we discussed. His efficiency is very good, around 40%, and his diagram you can see these kind of structure. It is not clearly visible, I think. Just wait. Okay, still it is not visible to read for participant, I think. Is it visible?
It is
I'm
visible,
sorry.
sir.
Okay,
Fourth
Yes,
okay.
generation
It
solar
is
cells.
not
It is
readable, but I think. Okay. So these kind of fourth generation solar panel will come, which will transparent also and look good. So we can utilize these kind of panels on our backpack, our cars, and other application for small application. There also we can utilize in head, helmet, everywhere we can utilize these kind of solar panels. So in future we will found a drastical change in the solar panel design and their looks also. Now, in conclusion, we can say that among all the four categories, So the solar cell has very continuously evolved toward the higher efficiency, lower cost, and better adaptability. While silicon cell is dominating today, and third and fourth generation technology represent the future of the solar energy. So it will take some time, but in few years it will drastically change the power generation as well as their costing. Nowadays we are paying around 3 to 2.5 to 3 rupees, but in future maybe that cost is going down. So now if we try to merge these kind of solar cells with another technology so that we can increase their production, uh, and we can utilize for both time, in daytime as well as night time, because we know that the solar radiation is available for 8 to 10 hours in a day. So and but we need electricity for 24 hours. So there's, if we merge with another technologies like if we connect with the grid, so we can utilize electricity for 24 hours. If we merge with the wind turbine, so that also we can utilize. If we merge with the battery, so whatever the surplus energy generate through the solar panel, that we can utilize in night hours by extracting power from the batteries. So I will show the three type of configurations which can provide 24-hour supply through the solar panels, solar power generation. So here you can see one is the DC coupled, another one is the AC coupled, third one is the hybrid coupled configurations. So these are the three configuration which we can utilize. So these are the small substations which can generate electricity for 24 hours. So DC configuration, it means we use DC bus, and our whatever the power generation, that also we will convert in DC. It means our load is DC, so we will directly provide the electricity in DC form. As everyone know, the power generation through the solar panel is in DC, but the other all the renewable sources, they are provided power in AC. So this is the one first configuration which we can utilize for DC power generation. Another one is AC coupled, so we will connect with the AC and that convert the DC power into AC and connect it with the bus bar and provide to our load, storage or other applications by utilizing converter or inverter applications. Then third one is the configuration with the hybrid. It means we can provide electricity to AC as well as DC load. So here also we can utilize the other renewable sources and make these power plant for available for 24 hours. Okay, so among all three, the third one is the hybrid DC AC coupled configuration is very uh, important and useful because it manage all type of loads demand, as well as it will store the energy when it is drained. Everything is managed by this hybrid DC-AC coupled configuration. But the major drawback with this one is very uh, intelligent converter is required. That if you see this AC DC, this is the control panel, and this control panel cost is around 40% of the whole system. So in this system, only the requirement of the control panel and the skilled person are required to maintain this kind of hybrid system. So if you see overall in the India, around 3 to 4% only hybrid system, though those are installed in India. Mostly AC or DC are installed. So this is the summary of that we already discussed. Now, type of power plant. So how many type of power plant we can design using the solar panels? So first one is install the rooftop for homes, business or factories. There we can install the rooftop setups. Similarly, for nowadays, for electric vehicle or transportations, there also we can install these kind of solar panel. Nowadays in India, so many trains are also having rooftop setup on their uh, top. The second one is mainly grid connected but can be off grid with battery storage. So the some suppose that in our house we install the power plant, but if we are not connected with the conventional utility system, it means called as a off grid system. But if we connected with battery, that is also comes under the off grid system. The another category of the solar panel is the grid connected solar system. So large scale installation connect directly to utility grid, because if we are generate electricity very large in megawatt, so we need to connect with the grid system, and they will distribute wherever the load requirement is uh, generated. Similarly, the generated electricity from mass consumption and feed into grid, that also we can do. So if you see in speed, the total area of the 700 hectares or 14,000 acres in the Bardala Bhalodi, the Tehsil, Jodhpur district, Rajasthan. Here the park has total capacity of 2245 megawatt and compared to 10 million solar panels. So this one is the biggest power plant of solar in India. Okay, and that place is like sand. There's a not useful land is there. So there we install this kind of power plant. Now various type of solar power plants. So these kind of solar power plant we can create by using solar panel. These are the names up here. I will show the pictures for all of them. uh, yeah, so these are the number of type of solar panel power generating stations. So for garden or some any places, we can utilize these kind of power plant which looks like tree, but it generates the electricity and light up in the night hours or day hours also. Similarly, for agriculture, for houses application, for building application, you can see the horizontally, the vertically they are connected. Some parking area there also we can connected these kind of solar panel. They may be tracking based. Now if I discuss about the tracking, there are three type of tracking in the solar panel. So we can utilize fixed axis panel installation. Second one is the one axis power generating solar panels. Then third one is the double axis power generating generator. It means we have three kind of axis tracking system for the solar panel installation. If we compare the fixed axis and double axis, the double axis having 35% more than power generate as compared to fixed axis. But the problem is that if we go through with the double axis solar panel installation, they have so many mechanical part and rotating parts. So ultimately their cost of maintenance that is increases. So we are not much go towards the double axis, but if we go through with that one, it means we increase our efficiency around 35%. Similarly, if we go through with the this one, this roof integrated solar panel, this is the field integrated. Then these are the many number of type of solar power plants you can see here. This is the this also implemented in India. This track solar panel that also implemented. I think many of power plant we already installed in India. So you can see I will show some major power generating. Yeah, here you can see the innovative approach in installation for solar power plant. One is the building integrated solar voltaic system. So in this kind of system, we attach the solar panel on the walls at every place. See, this type, this is the BIPV, it is building integrated PV panel. So it's look good also, but it cover whole area of the building and generate the electricity in the day hours. Similarly, the floating PV panels or canals. So floating PV panels, that also we can install like this. Here you can see UVB parallel power plant. So that also, and this one also floating power plant. So these kind of power plant we can install where the water is stable in a static form, not in the flow. So here also we can install the power plants. Then third one is solar canopy or PV parking. So that PV parking also we can install like here. You can see this one canopy. The last one is the PV along the highway. So highway roadside, that also we can install like here. Yeah, this here also this way. And this is also the PV panel installation on the roadside. This is also the here also we can install. So these kind of places we can utilize to generate electricity which are not useful. So there we can install. Now, the few example in India where we already installed these kind of power plant. So this is the floating solar power plant at Omkareshwar. That Omkareshwar is in the Madhya Pradesh, and here you can see this is the big solar power plant is installed, which is floating on the river. The next one is the agri power plant. So here they install power plant as well as they are doing their regular agriculture works also. So these kind of structure also we can create. The third one is the parking power plant. So this is also implemented in Kochi International Airport. Here you can see you can utilize electricity as well as we can charge our electric vehicles also, because in future the mostly vehicle they will shifted towards the electric vehicle. So that time number of charging stations are required, similarly as the petrol pumps. At every 10 to 15 kilometers there's some charging station. In current days or situation, there's a very few charging station, but they are also in the city location, not in the outer. So there's a limitation why we are not fastly growing towards the electric vehicles. So in future that also change if this kind of power plant we can install in every location. Now the last one, this one is roadside solar power plants that also we can utilize, and they are vertical bifusial solar power plant, which means they can utilize both side. Whenever the solar radiation strike, it will generate electricity from front side as well as back side also, because the solar panel not require directly solar radiation, they require the heat around 25 degrees Celsius. So it will generate the electricity, and that temperature is mostly in our house also, it's around 25 degree in normal days. So but in open environment the temperature is higher, so it will generate the electricity easily. So that biaxial is also very beneficial, and it is also increase the efficiency for power generation. Now, what are the factor affecting the solar power plant that also need to focus, because many people suppose that in domestical application many people they install rooftop setup, but they are not maintaining or cleaning their power plant, so that ultimately their efficiency of the power generation is decreases. Sometimes they may burn also, short circuited also, because of some uh, cleaning work or other work not properly happens. So first, if we see the solar irradiation, so amount of sunlight, how much amount of sunlight is directly strike on the solar panel, that is very important. so that it will increase the higher efficiency of the solar panel. Second was geo relocation. So all the solar panel they solar panel setup, we cannot install all our the places because it's required 3.5 kilowatt per hour meter square solar irradiation. If it is less than of that or that much only, so we cannot get higher efficiency from that solar panel. We cannot get the higher power production. Suppose that if we are our power that what we can say the revenue of the initial cost, if we get in 5 to 6 year, where wherever the solar radiation is around 5.5 or 6 or more than of that, so we will generate our we will recover our initial installation in few years. But if the radiation is very less, it will take 10 to 15 year to recover your initial investment. Okay, so it is very important to identify the location where the solar irradiation is more than 3.5 kilowatt per hour meter square. Okay, and the climate change also, it is very important whether it is frequently changing in the year, so that parameters also need to observe. The third one is the shading. So shading is very important. Suppose that if some building shadow is on the panel, so it will decrease the efficiency. Some tree or some other shadow if is coincide on the solar panel, so ultimately it decrease the efficiency. The fourth one is the panel orientation tilt. So this is the very important parameter. How much panel orientation and the tilt angle, what you set on that particular location to extract the maximum efficiency or maximum power from the solar panel. That is very important to fix. Then roof condition, the structure of roof strength and availability of space is very important. Then temperature. So if high heat reduce panel efficiency, we cannot say that every time solar radiation is good to generate the higher electricity, because the solar panel, they are very good if the temperature is between 30 to 40 degrees Celsius. Beyond this, if suppose that if temperature is more than 45 and it is still 2 to 3 months in a year, so it will damage the efficiency of the panel. So it is also one major parameter to check how much temperature at that particular location. If the temperature is higher, we need to maintain the cooling in higher temperature days like summer's day. That time we need to provide cooling also by utilizing the water uh, uh, on the solar panel. Then next one is dust and maintenance. So dust particle also decrease the efficiency of the solar panel. If, they will if we are not cleaning the solar panel, so they are accumulated and create some layers. So the panel did not get uh, clear radiation on that, so that also decrease the efficiency. Then panel efficiency, so higher efficiency panel generate more power. Then inverter efficiency, that also very important, which kind of inverter you are using. Then net metering, so net metering is also important to observe how much revenue we will generate or how much power we are selling to grid, or grid how much power we are taking from grid. So that net metering is applicable for both sides, consumer as well as utility. Then incentive, how much incentive the government subsidies on the panel in nowadays around 78,000 for 3 kilowatt power plant installation. Government will provide subsidy for 78,000. Then energy storage. So battery also play a very important role. If we are using lead acid battery, it will less cost and less maintenance, but their lifespan is very less. But similarly, if we are at the same time we are using lithium ion battery, so it will uh, its lifespan is also 10 to 15 years, and their maintenance also less. But the problem is that they are very costly as compared to lead acid. So these are the 12 parameters which affect the solar panel efficiency and their generations. Now, the future of the solar panels, so that we already discussed previously in previous slide, that perovskite solar cell, so that can be utilized. Suppose that in Morocco Semiconductor is building is 250-acre and 12 megawatt per site solar panel plant in Jinping, China. Also is Germany and Japan. There also they install this kind of power plant. Then floating power plant. So in Telangana, around 100 megawatt power plant is connected there. Then solar roads. So roads are also uh, uh, created in France, China, and Netherlands. So on these places, we are implemented this kind of solar setup. Then the research is going on. The focused, as I previously said, the perovskite solar cell, because they are having very high efficiency, but they are not uh, as comfortably used as compared to first generation solar power. So much research and work is going on this fourth generation solar panels. Then recycling of solar panels. So many people are saying that if solar panel also create pollution during the manufacture, then how we can say that it is renewable? But we don't agree on that point, because during manufacturing it's obvious that it creates some emission, but it is very less, because it reduced 25 years of emission while generating the electricity. So it is not good to say the solar panel manufacturing also generating the CO2. The third one is the solar cooling with thermal storage. So that cooling also on this part also some research work is going on. Similarly, some other work this okay, that is not related to. Okay, we'll go on next. Okay, now how many softwares which are used to design the solar rooftop setup? So I go through with literature and see so many softwares are available which can be utilized to design a proper PV system design. Suppose that the hybrid to PV says Incel, Solim, Watson. There are so many number of softwares are available. Some are free, some are having chargeable, and some software on the MATLAB based. So I go through with the literature and see their merits and demerits, and when they are implemented, what is their availability. So these are the some website also mentioned, their cost also mentioned when they implemented. So after analyzing all this software, I found that only two software are very easy and powerful tools which can design more accurate results as we go for the practical design of the system. So these two are the Homer, and another one is the SOMS. These two software are very useful and uh, very economical, but one is the uh, license based software which having charges to utilize for Homer. but that software charge is very less for 1 month, 3 months, 6 months or year. So all type of versions are available to utilize this kind of platform. So, if we talked about the Homer software, in that we can access many type of solar panels, many type of manufacturers, tracking system, their efficiency, the kilowatt, how much kilowatt you want. So all type of parameter are designed in this in the Homer software. Here we can utilize many kind of uh, different type of PV systems. So this software is implemented in 1992 and it is very globally accepted software. You can thousand of research paper on this software, and it is very user friendly. It's very simple to use, and you can design a system as well as you can publish papers also. So I'll show how it will work and what are the parameters it's required to design one system. So here you can see the what are the input parameter required for this software. So the software first is required the load demand. What is the load demand for that particular location where you are planning to design a rooftop setup or off-grid system or grid connectivity system, whatever system we are going to design. So their load data is required, and their load data is from only for 1 day data of hourly basis. It means they require 24 hours data for 1 day, and it automatically design that 1 day data in month, in year, or up to life cycle of the project. It means if your project lifetime is 25 years, so it automatically convert this load data for 25 years with incremental order. It means after 5 years again load will change, after 5 years again load will change. So accordingly it will change and manage the load data, and similar way it will uh, add the panels or other equipments also. So this is the beauty of this software to manage the forecasting data also. The next input data required, which is the that particular location, how much solar irradiation is available at that particular location. So this software is not only utilized for solar system design, it can also design wind, biomass, grid connected, hybrid system, all kind of system we can design with this software. The next parameter is the cost efficiency. So it required the cost data, whatever the system you are connecting. Suppose that if we are going to design one rooftop setup, in that we required one PV panel, another one is the battery, third one is the inverter, and fourth one, if for backup you are utilizing the generator. So all four parameter, all four component cost data required by this software. So and that cost is initial cost, replacement cost, and maintenance cost. If you put all this data, this software automatically optimize the whole system and uh, uh, suggest the best optimal solution with less uh, cost of energy, less efficiency. Less. It means less carbon emission, or maybe it show the 100% renewable fraction system. Renewable fraction means zero emission generated through this power plant. So in output, it will show the how much power generated through the renewable non-renewable source. It means if diesel generator is connected, so how much diesel generator is utilized till throughout the lifespan of the project. Similarly, how much power generated through the PE panel, how much power generated to other component if it is connected. So this is the parameter which it will show. The another parameter regarding efficiency and sizing, that also it will show. The another parameter is the initial investment, service and operation, total cost, net present cost, and cost of energy. These data also it will shows, and whichever is having less that will show on the top of the list. Okay, so this is the working of this software, and in this way, whatever the data required, I said in previous slide, this is the flow chart for the same. So no need to discuss this one. It's just repeated of that one. Then these kind of system we can design. If you want, you can only include PV, battery, and diesel. Other parameter you can remove. You must include system controller and load parameter. That also you need to include if you're going to design one solar PV panel system. So these are the data required for this software. As I told you previously, the if we are connect diesel generator, so how much rated capacity, how much tilt angle, how much capital cost, replacement, OM, and life cycle. These data we need to provide in this software. Similarly, for PV system, similar for diesel, similar for battery, for everyone, we need to put these data. So it will automatically design the system and show the results for best optimal solutions. So this, okay, this is purely going to another shift, so no need to discuss this one. Yeah. Okay, so up to this only, I will try to conclude that if we go through to design the PV system singly, so you must need to have backup power, and backup power you can utilize battery or diesel generator, or if you don't have that backup, it means you need to connect with the grid system, so you will get 24 hours of supply. So this is all about the PV panel. I will try to conclude. I try to include so many points regarding renewable, then PV, then their generation, their software, and their designs of system. So this is all from my end. If you have any query or anything regarding my presentation, you please ask. Am I audible?
Yes, sir. Yes, sir.
Okay. If any query, please ask. I try to include that software modeling also, but my software is not working because recently I formatted, so that is not happening. So for that, I prepared for that also, but software is not working.
If any of the participants are having any query, please put it here. You can ask directly or put it in the chat box.
Hello, sir.
Yes, please.
Sir, will you please highlight on radiation limit?
Radiation limit.
Huh?
Limit, it means how much temperature is there, or
Huh.
yeah. So as I told you, the solar radiation is minimum required is 3.5 kilowatt per hour meter square. If it is below than that, it means your panels not fully provide the output. Whatever their efficiency, they will give below than that. And if the solar radiation is higher than the temperature of 45, okay, so it will also decrease the efficiency of the solar panel, because due to heat, their solar panel molecule, they are excessive charge, and they are collide uh, frequently, so that their efficiencies decrease. So there's a two constraint. The solar radiation is not below than 3.5, and if it is go up to 7, it is good. Temperature, it is not below than 25 and not more than 45. So the solar panel will perform accurately and it will give higher output. Am I clear you?
Yes, sir.
Yeah.
Sir, you said by cooling, it can be efficiency can be improved.
Can you repeat?
Sir, in your talk, you said that by
Ha.
cooling technique, the
Yeah, yeah,
efficiency can be improved.
yeah.
Ah,
Because as I told you, if temperature is more than 45 and it is for more days, because in summers only 15 to 20 or 25 days, that time the temperature is more than 45 in some places. Okay, and if your solar setup is at that location, so due to cooling, again the molecule they are highly charged and collide, so they may be short circuit, or maybe because of heat their efficiency is decreased. So for that we can shower on the PV panels, so their cooling we can maintain the temperature. So in that way we can maintain their efficiency and increase also.
okay, sir. Thank you very much.
Okay, okay, thank you very much.
Sir, there are a few queries in the chat box. One is from Sandhya Gupta, madam. How can increase the stability of peroxide cell at room temperature?
At room temperature.
Yes.
No, if room temperature is around 25, then it is okay, it will work. But below than that, it will not work, because peroxide is not practically tested all the places and all the environment, because huge work is going on that. So the peroxide is panel is still under research, and most of work is going on that.
Sir, we have another. Okay. So someone want to ask something? So, sir, there is
Hello.
another. Okay, sir. Please
Hello.
continue.
Hello. I'm audible.
Yeah, yeah,
Yes.
please.
So my question is just simple. If we place a solar cell in space, so at which temperature it will damage or not? Or it's not about the temperature. I'm asking about the lifespan of solar system or the solar cell.
Yeah, solar cell, suppose that even they are on space, so space their temperature is very high. But on satellite, they provide one protective layer. If you seen some videos are came when our Mangalyaan is released, that time they show some one carbon protective part is connected in front of the solar panel, so that will protect from the higher temperature. So that's why the panel are working in space for 25 years. Otherwise it's very difficult to survive there, because sun is very near that time to that solar panel, so they may not work for longer life.
Sir, not near the sun. I'm asking you if we launch our solar panels into the sky above the
Huh.
earth, not
Huh.
near the sun, above
Okay.
the earth, where the temperature is 15 degrees Celsius. It's quite enough for the. Then how long it can survive for a solar panel?
Okay, you are trying to say the if we increase the height from Earth to a higher space, like you're saying.
No, no, above the thermosphere where the temperature is 15 degree, not more
Hmm.
than 15 degree in the dark space, where there is no dust, no satellite, and no much solar radiation, but a clear, pure solar radiation without high temperature. Then what is the lifespan of a solar panel? It will still 25 years or it will grow more?
It may grow more because it will not utilize. As I told you, minimum temperature required is 25 degrees Celsius,
Okay, the
and you're
minimum is
saying is 15 degrees Celsius. It means it will not using the solar radiation. So I don't think it will generate electricity also that time, because the minimum required is 25 degrees Celsius, and you're saying around 15 degrees Celsius. So it will not work on that.
okay, sir.
Even it cannot generate electricity.
Okay.
Am I clear you?
Yeah, sir, you are absolutely clear.
Okay, okay. Thank you. Anyone else?
So, is there any more questions? So, sir, there
Yeah,
is one more
yes,
Hello.
query.
There is a one question that will
Prithvi.
be getting its notes at the end of the. So are you able to share the PPT, sir?
Yeah, yeah.
Okay. Okay.
Huh.
Sir,
Okay, where?
there is one more query. Do efficiency depend on material or the preparation method?
It's on material. If material is good, so that no, both are parallelly important, because their design as well as the material both are very important to design a PV panel which is very high efficient, low cost, low flexible, lightweight. So they are not depend on the material, because material we already have material which good conductivity, but it cannot set on all the parameters, because our requirement is not only their efficiency, our requirement related to their cost, related to their design, related to their flexibility, related to their weight. So all the parameter we need to fix, so we cannot depend only one parameter. So it's true, we need to decide both.
Hello, sir.
Yes, yes.
Sir, actually, I have a question regarding the temperature effect on the solar panel output.
Hmm.
What if the temperature goes below 25 degrees Celsius? Will
Hmm.
there be any power production from the solar panel? Yeah, it will be zero.
No, if it is more than 25 degrees Celsius, you are saying that one. If it is more than 25 degrees Celsius, will it be produce power or not?
It
Is
is
it your
less than
question?
25 degrees Celsius, not more. Less than 25.
No, it will not produce the electricity, because the minimum required is that much.
But as we see the some spec sheet of the solar panels, so on
Hmm.
that spec sheet they have given the temperature up to the 10 degrees Celsius also. It's working temperature range.
The special some special design are for special application, not for the overall or general solutions. So they
Okay.
may install these, they may design these kind of panels according to their applications, but for journal it is not possible.
Yeah, as I have seen on the their spec sheet here, the working range is given. So that
Ah,
is below 25 degrees Celsius.
yeah, yeah, because they are very near to moon also. That time they cooling cool also. So, but they are designed very special in other conditions, not for all the applications.
Okay. If there is some
Ah.
snowfall is there, then in that case we will not get the power.
No, in that
Because
case,
there
we
is solar.
cannot. No, it is not possible to design any solar panel for the snowfall location or the cold countries. They are not install any. Suppose that many countries they have around 8 to 10 months with snowfall. So
Yeah.
there, these kind of power plant cannot be effective or efficient.
Okay.
Yeah.
Yeah. Okay. Okay. Thank you, sir. Thank you.
Okay. Even in India also, we can say that almost in out of 365 days, almost 10 to 15 days are cloudy days, whole
Yes.
year,
Yes.
in whole year. Okay, so that should be considerable. But if they that cloudy days is more than 6 months, 5 months, so how we can get a revenue from that power plant?
Yeah.
Whatever you
Generally we are
invested in
considering the.
initial, that is also not you will get.
Yeah.
Our
Generally we are
target
considering
is
the.
to get within 4 to 5 years. Whatever we invested, that we will generate in 4 to 5 years. Payback period, it means our payback period should not be more than 6 years,
Okay, sir. Yeah.
and we will get 19 year to 20 year the revenue only. Then only these kind of power plant are very effective or cost beneficial.
Okay. Thank you, sir. Thank you.
Okay.
Sir, there is one question in chat box from the
Yeah.
request Rex. Is there any material even withstand in summer?
Even in
Withstand in summer.
Summer, all the material are installed in summers.
Which stand? Means he's
Which
asking
is,
about which stand.
no, I'm not getting actually where it is. Question.
It is 7:27. Dr. S. The first question. At 7:27 p.m.
So it
7:27.
it says, is there any material even withstand in summer season?
In space, okay. Is it na? In space,
Sir,
any
good
material
evening,
is.
sir. Good evening, sir.
Yeah, yeah. Please.
Sir, you told that you have to maintain some temperature, no, in the summer. So you have to maintain there some temperature, no. If the
Yeah,
temperature
yeah.
increases above 45 degree,
Ah,
it will create problem, no. So is there
yes,
any
yes.
material even withstand above 45 degree?
No, no, no. Because with the 45-degree temperature is not all the location in India. Only few locations in India or some state having 4 or 5 districts, they are having more than 45-degree temperature in summers, but that also only for 15 to 20 days, not for a whole month or 2 month or during whole summer season. So for few days the panel can manage itself, no need to do anything. But these kind of temperature is still remain for more than 1 month. Like if you take Rajasthan location, their temperature is very high because the sand area is there. Okay, so there we need to maintain temperature while cooling. So the cooling you can give cold air or you can give water vapors on panels. So this is not applicable for all the location or everywhere. Am I
Okay,
clear?
thank you, sir. Thank
Yeah,
you.
yeah.
Yeah, yes, yes. Thank you, sir.
Okay, okay. Thank you, thank you.
Professor Atul Kale is asking the question, sir, why to use diesel generator with this?
Yeah. As we know, if you see the load cycle, suppose that I may start from morning 6 a.m. So our load demand is very low. Up to 10, the load demand is increased. Up to 12, load demand again increase. Up to 2 p.m., the load demand is on highest of the day. And again, it will decrease on 4, 6, 9, or from 9 to morning 6. It will again nearby 0. This kind of our load. Similar way our solar radiation also same way. Solar radiation start from morning 6, again it will go higher around 8, around 10. It will temperatures again increase and evening again is decrease. So same way our load is increased, similar way upon solar radiation also follow that way. So that is the another concept. Now your question, why we are using generator? Because our radiation is available 8 to 10 hours, so it will generate electricity for 10 hours, but our load demand is 24 hour. So we need to install extra solar panels to fulfill that load demand. And extra panel if you install, it means more than load, you have electricity more than the load demand. So the whatever the supply energy you have, that you need to store in the battery. So if you have battery, so you can drain this battery in the night hours and fulfill the load demand. That is the one solution. But if you don't have battery, or you don't have more number of panel as require your load demand, so you need to fulfill your customer demand for 24-hour supply. You need one more diesel generator to connect with your solar system, rooftop system, to fulfill their load demand during the night hours, as well as cloudy days, as well as winter days. Someday sun is not coming out, so your PE panel plant is not working. So how you will fulfill your, because your customer is asking, I will give 8 rupees, 10 rupees, but I want 24 hour of supply, but you give me 24 hours supply of electricity. So you need to manage how you will provide the electricity. So for that you need to add diesel generator or battery setup. That is compulsory. So it is only related to reliability. Am I clear your doubt?
Sir, as our next speaker is in the line, so
Okay, okay.
I request you to please, can he conclude, sir, here? Sir,
Yeah, yeah.
should we conclude?
Yeah, yeah, sure. Please,
Okay,
sure.
okay.
Sure.
Thank you. So, on behalf of the organizing committee of AICTE Atal FDP, I would like to express our sincere gratitude to our esteemed session expert, Dr. Yashwant Savle sir, for delivering such an enlightenment and insightful session on evolution of solar cell technologies and its PV system design. Sir, your comprehensive coverage from evolution of solar cell technologies to PV system design, along with valuable insights into renewable energy resources, innovative approaches in solar PV installation, factors affecting rooftop solar generation, future of solar power, and the use of software tool for designing hybrid renewable energy systems has greatly enriched the knowledge of all the participants. We are deeply grateful to you, sir, for sparing your valuable time, sharing your expertise, and contributing meaningfully to the success of FDP. Once again, thank you so much, sir, Dr. Yashwant Savle, sir, for your valuable support and inspiring interaction. Thank you, sir. Thank you all. Thank you so much.
Thank you, Rajni, and thank you, organizing team, to invite me and for giving the opportunity of lecture. Thank you, everyone, and all the participants who listened very well and asking the questions. Thank you.
Thank you so much, sir.
So, sir,
Thank you,
our
sir.
next speaker is in the line. Amol,
When
sir,
should I
please,
leave, madam?
yes, yes, sir, yes, sir.
Okay,
Thank
okay.
you so much, sir. Thank you so
Thank
much,
you.
sir.